Hello everyone, welcome back to Binju's Education, and our today's topic of discussion is the quantity comparison, and today we'll be discussing questions based on geometry. Okay. Now I have already uploaded one video on quantity comparison. We have already covered up one topic which was related to inequalities, and this is the second topic in the continuation of quantity comparison. So we'll be looking at approximately like 20 questions, which will be of considering of topics from lines, circles, then circles and quadrilaterals, then triangles, triangles and circles. Okay, and all the questions will be based on quantity comparison. All right. So let's start. We'll discuss one question so that you guys understand what exactly is quantity comparison if you're not aware of it, because this is a very important type of question. There are four types of questions which come in GRE maths, and this is like the most important one. Approximately 40% of the maths questions that you get in the exam are of quantity comparison. Okay, now first of all, we'll understand what a quantity comparison is, and then we'll move on to the specific problems from the geometry section. Now, what happens in a quantity comparison question is that you are given a statement, basically, which you have to consider as a fact, and information is given to you. So like in this case, the information given to you is x is an integer. This is the fact, or this is the information which we have to take it to be true. Now if x is an integer, which means x is going to be some value like, it can be -3, it can be -2, it can be -1, it can be 0, it can be 1, it can be 2, it can be 3, and so on and so forth. Right, x is an integer, it can be a positive value, it can be a negative value, it can be 0 also. We have to take all the possible cases into consideration. Now quantity a is x plus 1, quantity b is 1 minus x. Now using the information or using the fact given to us, we have to determine what will be the relationship, what will be the conclusive relationship between the two quantities, that is quantity a and quantity b. Now, what do you mean by conclusive relationship? It basically means that can we conclusively say that quantity A is greater? Can we conclusively say that quantity B is greater? Or can we conclusively say that they both are equal? Or we can't effectively determine the relationship between the two quantities. That is, for some values of x, quantity A is coming out to be greater. For some values, quantity B is coming out to be greater, right? In that case, we don't have a specific relationship. That's our target. Now, how are you supposed to approach these problems? So the first thing that you will do is, since you do not know which sign we have to use, because which of them is greater, which of them is smaller, we don't know that. So I'm going to put a question mark in between. So I'm going to make a box something like this, and I'm going to put a question mark in between because I do not know what the relationship is. Now, I'll use some principles which I know, that is, now, we know that since we have already done the basics of inequalities, you know what a linear inequality is all about, right? Now, whenever you add or subtract something on both sides of inequality, your sign of inequality does not change. Now, we have a variable x on both the sides. We also happen to have 1 on both the sides. The first thing that I'll do is I'm going to subtract 1 from both the sides. So I'm going to have x question mark, and this will become minus x. Then the next thing that I will do is I'm going to add x on both the sides. So plus x plus x. So this will become 2x and this will become 0. Right? Now you need to compare 2x with 0. Now if in case x is negative, then 2x will also become negative. If in case x is negative, then 2x will also become negative. If in case x is 0, then 2x will also become 0. And if in case x is positive, then 2x will also become positive. So since x is an integer, the value of 2x can be negative integer, it can be 0, it can be a positive integer also. Whereas the quantity b is always 0. So quantity a can be less than quantity b if in case x is negative. Quantity a and b can be equal also when x is 0. and quantity A can be greater than quantity B also when 2x is positive. So do we have a conclusive relationship? Can we definitely say that A is greater than B or equal to B or less than B? No, we can't conclusively say that because we do not know, like, x being an integer, it can be anything. It can be positive, negative, zero, right? So we don't have any conclusive relationship between the two things. Hence our answer is option number D. That is, the relationship between the two quantities cannot be determined. And that will be our answer. Okay, so this is what a quantity comparison is all about. You have a statement, you'll be given two quantities. Based on the statement or based on the fact given to you, you will have to compare which of the two quantities are greater or are they equal. This is what you need to compare. All right. Okay, now let's move on to question one. Now what you will be doing from here on is that you'll pause the video, you'll try the question yourself first, and then you'll play back the video and understand how to approach a particular problem. All right. So pause the video and try this question, please. Okay, let's see what do we have in this. Line L and M are parallel. Okay, so these two lines are parallel. ABCD and EFGH are a parallelogram. AB is greater than EF. Okay, AB is greater than EF. They both are parallelogram. This is given to us. Fine. And we have quantity A, which is area of ABCD. We have quantity B, which is area of EFGH. Now, if L and M are two parallel lines, one thing is sure, that the perpendicular distance between the two parallel lines will always be constant. The perpendicular distance between two parallel lines will always be constant. Now, if we talk about area of a parallelogram, we know that area of a parallelogram is nothing but base times the height. Area of a parallelogram is nothing but base times the height. So let's do one thing. In case of ABCD, let's consider base to be AB. And in case of EFGH, let's consider base to be EF. Right? Now, one thing is sure, which is which is also given to me in the fact, that is AB is greater than EF. So base AB is greater than base EF. Now, area of a parallelogram is base times the height. Now, the only thing we need to figure out is height. Now, what's height? Height is nothing but the perpendicular distance from the opposite side onto the base. Height is nothing but the perpendicular distance of the opposite side onto the base. So if I want to calculate the height of this parallelogram ABCD, then the height of ABCD can be calculated as something like this, that this will be the height. Or if you want to calculate height of EFGH, then this will be the height. Now, since DC is parallel to AB, also HG is parallel to EF, so I can say that the two heights, that is, let's call this H1, let's call this H2, we can say that the two heights of the two parallelograms have to be equal, because the perpendicular distance between two parallel lines never changes. So the heights are equal, which means if we talk about the area of the two parallelograms, it's only dependent upon their bases. If we talk about the area of the parallelogram, area of the two parallelograms, it's only dependent upon the two bases. So for whichever of the two the base is greater, the area of that parallelogram will be greater. Now in case of ABCD, the base AB is greater. The base AB is greater than the base EF. So if the base of ABCD is greater, since the height is same, the area of ABCD has to be greater, which means quantity A is definitely greater, no matter what happens, no matter what the value of height is, because the base is greater. Hence, quantity A is definitely greater, and our answer is option number A. And our answer is option number A. Okay. All right. Let's move on to next one. Pause the video and draw this question, please. All right. Let's see how we can solve this one. In the above given figure, angle D is 100 degrees. Okay, this is 100 degrees. Quantity A, that is angle D minus angle A. Quantity B is angle C minus angle B. Okay. Now we have a circle and we have an inscribed quadrilateral. Now if you have an inscribed quadrilateral, then quadrilaterals like these are known as cyclic quadrilaterals. This is a cyclic quadrilateral. ABCD is basically a cyclic quadrilateral because all the four vertices of the quadrilaterals lie on the circumference of the circle. Okay, lie on the circumference of the circle. Now, if angle D is 100 degrees, now we know this one property of cyclic quadrilateral, that is sum of the opposite angles is always equal to 180 degrees. Sum of the opposite angles is always equal to 180 degrees, which means if angle D is 100 degrees, then angle B is equal to 80 degrees. That's for sure. Similarly, if I consider this angle A to be x, then I can say that angle C will automatically be 180 minus x. Now let's plug in the values. We have angle D minus angle A, so that will be 100 minus x, and we have angle C, which is 180 minus x minus 80. Now when you solve this will simply become 100 minus x. So quantity B is 100 minus x, quantity A is also 100 minus x. Now no matter what will be the value of x, 100 minus x will have to be equal, right? So what will be our answer? Our answer will simply be C. That is, the two quantities are definitely equal. That is, the two quantities are definitely equal. Correct? So 3 is our answer. Correct. Okay, pause the video and draw this question, please. Okay, let's see how we can solve this one. Three sides of an acute angle triangle are 8, 12, and k. Quantity A is k and quantity B is 6. Now, three sides are 8, 12, and k. Okay, first let's figure out what will be the value of k, then we'll come down to this quantity part later on. So if I use the inequality, triangle inequality, then we know that sum of two sides is always greater than the third side, and difference between the two sides is always less than the third side, which means the value of k will be less than 20 and the value of k will be greater than 4. Okay, but now the question is specifically that we need an acute angle triangle. Now even if I consider k to be an integer value, which effectively is not given to me in the question, but even if I consider k to be an integer value, then values such as 5, 6, 7, 8, and so on and so forth up till 19 will satisfy. I'm only taking the integer part. Okay, but now the problem is these values of k that I have find out, these values of k which I have figured out, 5, 6, 7, 8, and so on and so forth up till 19, it may happen that for some of these values this triangle 8, 12, and k will not be an acute angle triangle, it may be an obtuse angle triangle also. Okay, because this inequality just gives me all those values of k for which 8, 12, and k will become a triangle. What kind of a triangle, we need to dig further. Now since it's an acute angle triangle, so the property which you need to remember, the property which we have already discussed when we were doing the basics of triangles. Okay, if you do not know then the properties of the inequality part for an acute angle triangle or for an obtuse angle triangle, then go to the video basics of triangles, you'll find all those properties there. So for acute angle triangle, square of any of the sides is always less than sum of the squares of the other two sides. This is always true. So 144 should be less than 64 plus k square, or 144 minus 64 will become 80, or k square is greater than 80. Now I know that 9 square is 81. We know that 9 square is 81. If k square is greater than equal to 80, sorry, if k square is greater than 80, then the value of k will basically be greater than root of 80, which means k should be greater than or equal to 9, which means k should be greater than or equal to 9. Now you need to apply the property the other way around also, because it may happen that k is the longest side, right? It may not be definitely for sure that 12 is the longest side. It may also happen that k is the longest side. So in that case we will also say that k square is less than 12 square plus 8 square. So k square is less than 144 plus 64, or we will have k square is less than 208. Now again we know that 15 square is 225 and 14 square is 196, which means the value of k has to be less than equal to 14. I'm just considering the integer part, okay? Otherwise it will come in decimal, that's for sure. We're just considering the integer parts. We'll get the answer from the integer parts also, don't worry. Now, if we want this triangle to be an acute angle triangle, we have to figure out a common answer for the four inequalities. K is less than 20, k is less than equal to 14. So k has to be less than equal to 14 because that will be the common part. If you want, you can draw on a number line also. K is less than 20 and k is less than equal to 14 also. So this is the common part, which is k is less than equal to 14. Second one is k is greater than 4, k is greater than equal to 9. K is greater than 4, k is greater than equal to 9. Again, if you want, you can draw this on a number line also. K is greater than 4, k is greater than equal to 9. This is the common part. So we can say one thing for sure, that the value of k will be between 9 and 14 including both the values. The value of k will be between 9 and 14 including both the values. That's for sure. Now, whether you consider the decimal part of this conclusion or just the integer part of this conclusion, one thing is for sure, that k cannot be less than 9. Because if k is less than 9, then anything less than 9, comma 8, comma 12, anything less than 9, comma 8, comma 12 will not make an acute angle. Will definitely not make an acute angle. It's not possible. Okay. So if we talk about this, the value of the k, it has to be from 9 to 14. Now all these values from 9 to 14 will definitely be greater than 6, whether decimal or simply integer part. So quantity A is k and quantity B is 6. So I can say one thing for sure, that the value of k is definitely greater than 6. The value of k is definitely greater than 6. It has to be. Otherwise, it will not be an acute angle, triangle. It's not possible. So what exactly will be the value of k? There are like a lot of possible values. Even if we consider only the integer part, then also we can have 9, 10, 11, 12, 13, 14. That's just the integer part. But one thing is for sure, that k will be greater than 6. So what will be our answer? Our answer is option 1, that is quantity A is greater. And that's our answer. Okay. Alright. See again, the point of solving quantity comparison is pretty simple. It's very straightforward. You have to first understand the fact given to you, figure out what all possible answers can that fact give to us, and then check the two quantities, then try to evaluate the two quantities, then compare the two quantities. That's the whole point, nothing else. All right. Okay, pause the video and draw this question, please. All right, let's see what we can do with this one. In the figure above, EFGB is a square, okay. AB is 6, so this entire part is 6. AC is 10, this is 10. Now if EFGB is a square, so this angle will automatically be 90, which means ABC will be a right angle triangle, and which means BC will be equal to it. Which means BC will be equal to it. Now since EFGB is a square, which means all the sides will be equal. So let's take this to be A, this will also be A, this will also be A, and this will also be A. Which means AE will become 6 minus A, and GC will become 8 minus A. This is what we can conclude. All right. Now, what's given to what has been asked to us? Quantity A is area of square EFGB. Okay. So this is the area. So this is simply equal to A square, and quantity B is 10, which basically means that I need to somehow figure out the value of A, because that can only give me the area of this square. Okay. Now if angle B is 90, so if GC, this will also be 90, and this will also be 90. If I take this angle to be theta, so this angle here will automatically become 90 minus theta, which means this angle here will be theta, and which means this angle here will automatically be 90 minus theta. Now I can say that triangle AEF will be similar to, now triangle AEF. A is 90 minus theta, E is theta, sorry, E is 90, and F is theta. So we have 90 minus theta, 90 and theta. 90 minus theta is F, 90 is G, and theta is C. So triangle AEF will be similar to triangle FGC using double A similarity. Effectively in this case we have all three angles equal, but we say that as a double A. You can also call that as triple A similarity, it's one and the same thing. Which means I can say that AE divided by FG will be equal to EF divided by GC will be equal to AF divided by FC. So what's the value of AE? AE is 6 minus A. FG is A. EF is again A. And GC is 8 minus A. I think these two are sufficient. We don't have to write AF over FC, it's not required. So let's cross multiply. This should give us A square, and this will give us 6 minus A into 8 minus A. So this will give us A square. This is 48 minus 14A plus A square. So A square and A square will cancel out. So I will have 14A is equal to 48, or A is equal to, I can divide both sides. I can write 48 by 14, and 2 will be removed, so this will become 24 by 7. Now 24 by 7, 7 threes are 21, so this will be 3 plus 3 over 7. Or you can write 24 over 7, that's completely your call, that's the value of A. Now we need A square, so this will basically become 24 by 7 square, or you can write 3 plus 3 by 7 square. So 24 is 576 divided by 49. Now we know that 49 into 10 is 490, right? So 576 divided by 49 will be roughly around 11.5 or 12. as a fraction, this will be approximately equal to 12. Now, one thing is for sure, anything approximately equal to 12 will be definitely greater than 10. It will be definitely greater than 10. So, one thing is sure, that is quantity A is greater than quantity B. One thing is sure, that is quantity A is greater than quantity B. So, this becomes your answer, that is A is greater. Again, see, the whole point is you understand the fact, you solve the fact part first, then you come on to the comparison part. Okay. All right, let's move on to the next one. Pause the video and draw this question, please. Okay, let's see what we can do with this one. A sphere M and a cube C has equal volumes. Okay, so we have a sphere M and cube C, and they both have equal volume. So volume of sphere M is equal to volume of cube C. 4 by 3 pi Rm cube is equal to AC cube. This should be our conclusion from first one. Okay. Whereas another sphere N and a cube C have equal surface areas. So 4 pi Rn square is equal to 6 AC square. So we need to figure out the relationship between radius of sphere M and radius of sphere N. Okay. We need the value of Rm and Rn. Okay. So let's solve the first one. Rm cube is AC cube into 3 divided by 4 pi. Now, if you talk about 3 divided by 4 pi, so pi is 3.14. So approximately I can say that this value will be roughly equal to 1. It will be definitely less than 1. It will be like 0.95 or 96 something. But roughly I can say it will basically be equal to 1. And if we talk about cube root of 4, now square root of 4 is 2. But if we talk about cube root of 4, which three numbers should we multiply so that we get the result as 4? So I think it should be roughly around 1.4 or 1.5. It should be roughly around 1.5 because if you talk about 15 cube, that is 3375. Right, so it should be somewhere around like 1.5, 1.6. So let's just say that the value of Rm will be AC divided by 1.5, 1.6. I'll just say that that's more than sufficient, because if I don't have a calculator then I can't do anything. I'll simply say that okay, it will be roughly around 1.5, 1.6. Now if we solve the second part, so I can say that Rn square is equal to 6 AC square divided by 4 pi. Now this 4 into pi, this is 4 into 3.14, this is roughly equal to 12. So Rn square is equal to AC square divided by 2, because 6 over 12 is 2. So I can say that Rn will be equal to AC divided by 1.414. Now I do not know the exact value of cube root of 4, but I know it's roughly around like 1.5, 1.6. But one thing is for sure, it has to be greater than 1.4. That's like definitely true. I'm definitely true of that part. So the value of Rm will be AC divided by 1.5, 1.6, and the value of Rn will be AC divided by 1.414. Now the denominator for Rm is greater. The denominator for Rm is greater, which means the overall value of Rm will be smaller. Which means the overall value of Rm will be smaller. So one thing is for sure that Rm, that is the radius of sphere M, will definitely be less than radius of sphere M. Since the denominator of Rn is smaller, so the overall value will be larger. So if you have to compare the two things, we can say that the radius of sphere N is greater, which means quantity B is greater, and hence 2 is our answer. Which means quantity B is greater, hence 2 is our answer. Okay. So this was a bit calculative, no denying on that part, but yet it was still doable. Yet it was still doable. All right, so we are done with this. Now try question number 6. Pause the video and try this question, please. All right, let's see how we can solve this one. So we have given a circle and length of the diameter AC is 10. It's given to us that this AC is the diameter, which means it will pass through the center O of the circle, and the length of AC is given to us as 10. Now B lies on the circumference. It's an angle made in the semicircle, which means this angle has to be 90 degrees. Area of triangle ABC, and we have 25 on the other side. Now we do not know what will be the length of BC, what will be the length of BA, but if we use the Pythagoras theorem, I can say that BC square plus AB square is equal to AC square, which means BC square plus AB square is equal to 10 square, and this is simply equal to 100. If we talk about area of the triangle, then area of the triangle will be half base into height, so that is half into BC into AB. It will be half into BC into AB. Now, the thing we need to observe here is that remember one thing, whenever the sides of the triangles are not given to us, let's talk about just about the right angle triangle. If in case just the hypotenuse is given to us and the remaining two sides is not given to us, and they ask us to figure out the area of a triangle, and they ask us to figure out the area of the triangle, in that case you can only find out the maximum area of the triangle. In that case, if the two sides are not given to us, then you can only find out the maximum area of the triangle. You can never figure out minimum area of a triangle. It's not possible, right? So you can definitely figure out the maximum area of the triangle, but you can never figure out the minimum area of the triangle. So what we will be doing here is that we'll try to figure out the maximum area of triangle ABC. We will try and figure out the maximum area of triangle ABC. Now area of triangle ABC is half BC into AB, where BC square plus AB square is equal to 100. Now if I want to maximize half BC into AB, I have to maximize this product BC into AB, right? That should be my goal, where BC square plus AB square is 100. Now basically the question is, the bottom line is, the sum is constant and you want to maximize the product. The basic line is sum is constant, which is 100, and you want to maximize the product. This is our goal. This is our goal. Now remember that whenever sum is constant and you have been asked to maximize the product, the simple thing is you have to make the numbers equal, or you have to make the quantities or the variables equal. So in this case, if I want to maximize BC into AB, If I want to maximize BC into AB, my simple goal here would be BC is equal to AB. It will be BC is equal to AB. Let's consider both of them to be x just for the sake of calculation. So I will have 2x square is equal to 100, or the value of x is equal to under root of 50, which means the maximum area of the triangle that we can have is half into x square, and that is half into 50, which is simply equal to 25, which is simply equal to 25. Now this is the maximum area. This may happen, this may not happen, we do not know. For example, just to contradict us, if I take BC to be 6 and if I take AB to be 8, because 6 square plus 8 square is again 10 square. Now if you consider BC to be 6 and AB to be 8, in this case our area will be half into 6 into 8, which is equal to 24 square units. This is also a possibility. It may happen, it may not happen, that's another question, right? But this can definitely happen. So the maximum area that we can have is 25 when the two sides are equal. But what if the two sides are not equal? Because that's not given to us, right? So area of triangle ABC, which is quantity A, this value is definitely less than equal to 25. It will never be more than 25, but it can be less than 25, depending upon the length of BC and AB respectively. So do we know the length of BC and AB? No, we do not know that. So we'll have to take all the cases into consideration. Which means if you talk about quantity A can be equal to 25, or it can be less than 25 also. Which means quantity A and B are equal, or quantity A can be less than quantity B also. So do we have a specific relationship? No, we don't have any specific relationship. Which means our answer is simply 4. Which means our answer is simply 4. That's it. Okay. Alright, let's move on now. Pause the video and try this question number 7, please. Alright, let's see what we can do with this one. Now again, it's given to us that AC is the diameter of the above circle. That's it. And we have a triangle ABC where this point B lies inside the circle. Measurement of angle ABC, and we have 90 degrees on the other side. Okay. Now before we actually solve this question, there is one point which I would like to discuss again. This is something I discussed when I was teaching you this the basics of geometry. Now what happens in case of GRE and GMAT is that the figures are not up to scale. Right now, most students sometimes don't understand the actual meaning of this term, that figures are not up to scale. Okay, they go as far as saying that, sir, how can we be sure that this point B has to be inside the circle? Now, see, when you talk about the term that figure is not up to scale, that basically means that the dimensions cannot be compared. That is, if figure is not up to scale, then you cannot say that AB will be greater than BC or AB will be less than BC. You can't conclude that. But you can't go as far as saying that we do not know whether this point B is inside the circle or outside the circle. This should be given to us. This is not scaling. This is not scaling. If we have to go this far, then someone may even come up with this question that how do I know that whether ABC is a triangle? Because that is also not given to me in the question, right? So understand the difference between a scaling and misinterpreting a figure. Now let's suppose if this line was not given to us, that AC is a diameter of above circle, and simply this figure was given to us. In that case, it would have been a valid argument if you were to say that AC is not the diameter. I would have completely agreed on this part, because first of all, on AC we do not have this dot and O, which is a universal symbol of center. I do not have this. Neither it is given to me that AC is a diameter. Neither it is given to me that AC is passing through the center of the circle. Right? AC is simply a line segment whose endpoints lie on the circle. Then in that case, it can be a chord also. Now, it's not necessary for a chord to be a diameter. Okay, now that's a valid argument that what you're saying is mathematically also correct. But you can't go as far as just because the fact that GRE says that the figures are not up to scale in the exam, that does not mean that point B can lie outside the circle also. You can't go that far, right? Otherwise, it would be very difficult for us to solve a geometry question. Okay, so the point B lies inside the circle, that's for sure. But whether AB is greater or whether BC is greater, that we do not know, because the dimensions, unless and until the figure is up to scale, the dimensions cannot be considered. That's the whole point. Okay, assumption should not be taken into consideration. So this is the assumption. If you are assuming that CB is greater than AB, then this is incorrect because figure is not up to scale. But B point is definitely inside the circle. That's for sure. There are no second thoughts on this. Okay. Okay. Now AC is the diameter of the above circle. So let's have a center O. Measurement of angle ABC and quantity B is 90. We need to figure out this angle B which lies inside the circle. Now, the simplest way of understanding this problem is that what we will do is we will basically extend CB, and let's say that when we extended CB, the point where this CB intersects this circle is B dash, and let's connect this B dash with this point A also. Now, this triangle A B dash C, this triangle A B dash C will basically be a right angle triangle. This angle will be 90 degrees, right? Because AC is the diameter and B dash is the angle in the semicircle. So B dash angle will be equal to 90 degrees. Now what I'll do is I'll consider this angle to be theta, which means this angle will automatically be 90 minus theta, which means this angle, that is angle ABB dash, this angle will automatically be theta, which means this angle here, which we need to figure out, will automatically be 90 minus theta, will automatically be 90 minus theta. Now theta can't be 0, right? Theta has to be some angle. Even if it is 0.5 degrees, then also it's fine, but it has to be some angle. So if you talk about the measurement of angle ABC, this angle is definitely 90 minus theta. Now theta will be a positive number, which means quantity A will be less than 90 degrees. Which means quantity A will be less than 90 degrees. So quantity A is less than 90 degrees, quantity B is 90. Which of them will be greater? B has to be greater. B has to be greater. So in this case, 2 becomes our answer. In this case, 2 becomes our answer. That's it. Pause the video and draw this question, please. Okay, let's see what this question says. We have a parallelogram PQRS. So let's quickly draw that. M and N are midpoints of PS and QR. Okay, so M and N, these are the midpoints of PS and QR. A and B are 2 points on MN. Okay, so we need to draw MN first of all. Let's take 2 points. One is A, another is B. Okay, now that is all that is given to us. No other information is given to us. Now quantity A is area of PAQ. Okay, so PAQ, and quantity B is area of RBS. RBS. This is what it is. Okay. Now these are the two quantities which we need to compare. Basically, they want us to figure out the relationship between area of these two triangles. Now, if PQRS is a parallelogram, now in parallelogram we know that opposite sides are equal in parallel. So PQ will be parallel to RS. PQ will be equal to RS. Also, since M and N are the midpoints of their respective sides, then that means NM will also be parallel to QP, which is parallel to RS, and NM will automatically be equal to QP, which is equal to RS. Okay, all right. Now, if you talk about area of the triangle, area of a triangle is nothing but half base into height. Basically, what we need to compare is we need to compare the bases of the two triangles and heights of the two triangles. That is what we need to compare. So let's do one thing for this triangle PAQ. Let's take base to be PQ. And for this triangle RBS, let's take base to be RS. Now PQ and RS will be equal. Now PQ and RS will be equal because in case of a parallelogram, opposite sides are equal. Now it's just the height. Now when you talk about height, height is the perpendicular distance of the opposite vertex from the base. So this is what height is going to be. Okay, this is what height is going to be. Let's call this h1. Let's call this h2. Now N and M are basically the midpoints of the respective sides. So NM is a line which basically divides this parallelogram into two equal parts. NM is a line which divides this parallelogram into two equal parts. So can I say that the perpendicular distance of NM from RS as well as from QP, the perpendicular distance of NM from RS as well as from QP have to be equal? That is h1 has to be equal to h2, right? The two perpendicular distance needs to be equal because nm lies exactly in the middle. So from the middle to both the edges, the distances have to be equal. So if you multiply this by h1 and if you multiply this by h2, these two quantities will certainly be equal because the bases are equal as well as the heights are equal. The bases are equal as well as the heights are equal, hence the two areas have to be equal. Hence the two areas have to be equal, which means our answer is simply C or 3, that the two quantities are equal. That's it. Okay. All right. Let's move on to the next one. Pause the video and draw this question, please. Okay. Let's see how we can solve this one. This is actually a good question, a kind of question which you can expect in your exam. So in a right angle triangle PQR, so this is 90 degrees. Right angled at Q, X and Y are midpoints of the respective sides. Okay. T is a point on QR. PQ is 6. So this is given to you as 6. QR is 10. So this is given to us as 10. Okay, fine. No problem. This is given to us as 10. So area of PX ty and quantity B is 12. Okay. Now area of PXTY, which is basically a quadrilateral, can be divided into two triangles as something like this, right? Now, since x and y are the midpoints of their respective sides, so one thing is for sure, that is this angle will also be equal to 90 degrees. This angle will also be equal to 90 degrees. Okay, now x being the midpoint, this length will automatically be 3 and this length will also be equal to 3. That's for also sure. Okay. Now, if I talk about the midpoint theorem, since we have discussed that midpoint theorem when we were doing similarity of triangles, I can say one thing for sure, that is the length of xy has to be 5. So midpoint theorem was something like this. Let's suppose you have a triangle. Let's call this P, let's call this Q, let's call this R. And let's say we take 2 points A and B, which are the midpoints of the two sides PQ and PR. Okay. Now when you connect A with B, then what will happen is AB will be equal to half of QR and AB will be parallel to QR. AB will be half of QR and AB will be parallel to QR. So using that property, I can simply say that XY will be equal to 5. XY will be equal to 5, which means one thing is for sure, that if I talk about area of triangle PXY, it will be equal to half into 3 into 5, which is equal to 7.5 square units, which is equal to 7.5 square units. Now the only goal is we need to figure out area of triangle XYT. We need to figure out area of triangle XYT. Now let me draw that the below portion somewhere here. So this is X, this is Y, and this is what the portion is. And we have been asked to calculate the area of this triangle. This is what we need to figure out. This is given to us as 5. This we know is 90 and this part is 3. Now the problem in calculating the area of this triangle XYT is that we do not know where this point T lies. Where this point T lies. But the good part is we know that XY will be parallel to QR. XY will be parallel to QR. So this angle is 90 and this angle is also 90. Because PXY, this angle here, PXY, this was 90. So the angle just below it, which is QXY, that also has to be 90. Right? Now if angle QXY and angle Q, they both are 90, which means XY has to be parallel to QR. Now, if you want to calculate area of triangle XYT, let's consider base to be XY. Let's consider base to be XY. Then the only thing that we need is the perpendicular distance from the opposite vertex. And it would be this. Let's call this some value S, for example. So we just need the value of TS. That's the perpendicular distance between QR and XY. Now, interestingly, this distance is already given to us. If you'll observe carefully, you'll realize that the value of TS is equal to value of QX. The value of TS is equal to value QX, which is equal to 3. So if you want to calculate the area of this triangle XYT, if we consider XY to be the base, then QX will automatically be the height. And the area of this triangle will again be half into 3 into 5, which is again equal to 7.5. which is again equal to 7.5. So the area of triangle PXY is 7.5. Area of triangle XYT is also 7.5, which means the area of the entire quadrilateral will be equal to 15 units. The area of the entire quadrilateral will be equal to 15 units. And 15 is definitely greater than 12, which means quantity A is greater. Which means quantity A is greater. And one is the answer or A is the answer, whichever way you want to put that. Alright, let's try one more question for this video. Pause the video and try this question number 10, please. Alright, let's see what it says. O is the center of the above circle. Length of AB is 14. Quantity A is area of the triangle. Quantity B is 49 pi. It's a very simple question. It's not that difficult. Now, if length of AB is 14, now AB is a chord, right? A chord which is not a diameter basically, because AB is not passing through the center of the circle. So if I were to draw a diameter, I can definitely say that the diameter of this circle will definitely be greater than 14, because the diameter is the longest chord, right? No other chord is equal to diameter, or all the other chords are less than the diameter. So diameter is definitely greater than 14. That's for sure, right? So if diameter is greater than 14, which means radius will be greater than 7. And if we talk about area of a triangle is nothing but pi r square, which is basically equal to pi greater than 7 square, which is basically greater than 49 pi, which is greater than 49 pi. So quantity A is definitely greater than 49 pi, and quantity B is just 49 pi, which means which of them will be greater? Quantity A will be greater. So one is our answer. This was typically easy, right? So guys, this is basically what quantity comparison is all about. This is what we need to understand as far as the quantity comparison is related as far as for this topic geometry. I'll be making one more video where I'll be discussing 10 more questions on quantity comparison. Alright, so that will be all for this video. Thank you so much guys. Keep watching and keep learning. And if you haven't subscribed to the channel, please do that. Please share the videos with your friends also who are preparing for exams like GRE, GMAT and SAT. And if you have any concerns, if you have any questions, if you have any doubts, you are more than welcome to ask us anytime. Right? Thank you so much guys. Keep watching and keep learning.